Hi everybody, Sahil Bora here from C++BetterExplained.com, and in today's video I want to share with you guys an interview question that I got a couple of years ago in related to firmware engineering. And this firmware engineering question that I got in my interview question was related to designing a struct. And I'm going to put up this question in front of you guys here today, where it's saying you have these elements outlined here. How would you order these elements in a struct? And when I got this question, when I first got this question given to me, I actually didn't know the best way to answer it, because my background was working with C++ in higher level situations, not in like very low level situations in like microcontrollers that were very powerful. Because in this position that I was applying for, I actually was working with microcontrollers that weren't as powerful. They were using 8-bit microcontrollers in their hardware. And so when I was answering this question, I was kind of like making stuff off the top of my head with the experience that I had at the time. But in this video today, I'm actually going to be explaining how to actually answer this question properly in two parts, so that it can give you an insider's edge in case you get this question in an interview context, and in case you are working in firmware engineering and you need to utilize utilizing the best performance design techniques and when you're using structs. So let's get into the solution of actually answering this question, which I'm going to be using PowerPoint slides today to best showcase how to answer this question. Okay guys, so here's the question again, where this is the question that I was showing you guys at the start of the video. So the question is asking, you want to create a struct containing the following elements, and how would you order the elements and why? And there's two parts of this question that you need to understand: the sizes of the different types of variables that are being shown in the struct, and the understanding of the concept of memory padding. So the first part we'll cover here, which is pretty basic. So the first part here is covering our understanding of the different sizes of the different sizes and types of variables that we have. So in this table here, we can reference the different variable sizes that we have here in the variables that we're given. So a uint32t variable is going to be 4 bytes in size. A uint t variable is going to be 2 bytes in size, and a uint t variable and an int8 t variable, they're both also going to be 1 byte in size. So that's the first thing that we need to that could be easily understood. The different variable sizes in C and C++ programming. Next thing that we need to understand is the concept of structure padding. Now this next couple of slides are actually from another video called Structure Padding in C, which you can also search up on YouTube, and it's actually a great video explaining structure padding. So I need to give credit when credit's due. So the thing with structure padding is you need to understand that with the CPU is that it doesn't read like 1 byte at a time from memory. It reads 1 word at a time. So it really depends on like what different processor that you're using at the time. It can really range from like an 8-bit processor that you're using from like a very basic microcontroller to a hardcore 64-bit processor a hardcore 64-bit Intel processor that you might be using on your desktop computer. So the thing that we need to understand is that it reads at 1 word at a time. So if we have a 32-bit processor, that means it's actually accessing 4 bytes at a time, which means the word size is 4 bytes. And then if we have a 64-bit processor, that also means that it's accessing 8 bytes at a time, which means the word size is 8 bytes. So when we look at this structure that we have here, struct ABC. So we have three variables here. So we have char A and char B, which are both 1 byte in size, and then we have int C, which is 4 bytes here. So this is A, and this is B, and then C is the C bytes is highlighted in blue here. So it's 1, 2, 3, 4, and since so whenever we want to read the values stored in variable C, 2 cycles are going to be required to access the contents of variable C, because in the first cycle, the first 2 bytes can be accessed, and then in the second cycle, it's going to be accessing the last 2 bytes of the integer C. And this is in the context of a 32-bit architecture. So the best way that we would design that structure that was outlined in that question, the best way I would design it is that firstly that I would put the int32 variable first, because that's the biggest one, and then I would put the uint t16 variable second, because that is 2 bytes. So that's so the total size is currently 6 bytes at the moment, and then I'll put int 8, which is 1 byte in the middle, and then after that I would put the uint 8 variables straight after. So these are 1 bytes. These 2 variables here, node address and access level, are 1 byte each. So that makes it 4, 6, 7, 8, 9. This would make it this would make this entire struct size around about 9 bytes. And then the reason for ordering this design is because by ordering the elements this way, we are minimizing padding between the elements, and to ensure that the struct's overall size is more compact. So this is beneficial for memory usage and cache efficiency. So just to recap, uint32 is 4 bytes, which is the largest. uint16t is 2 bytes, which is the next largest. int 8 is 1 byte, which should be aligned on a 2 byte boundary, and uint 8, we've got 2 variables of that, is 1 byte, which is the smallest. So to recap, that would make that total struct size around about 9 bytes. And in a given scenario, say that we're using a 32-bit processor, it would likely use 2 cycles to read that struct. So there you have it, guys. So that's me answering the question of how I would answer that interview question of designing that struct. I hope it helped you guys out. And if you have any further question, leave a comment down below in the video, and I'll be able to answer your question. Thank you so much for watching, and if it helped you out a lot, feel free to subscribe down below and to smash that like button down below.